Hello everyone, welcome to chemistry class. Here we are with another video of the chapter number 2. In this present video we'll be talking about the energy changes that are going on in the various kind of changes around us. Sometimes the energy may be produced or given out in a particular change, and sometimes it is absorbed in the particular kind of the change. The changes we have seen already, that is physical and chemical changes. If you want to know about the details of these type of the changes, you can refer to the previous videos related to chapter number 2. So let us begin our today's topic here. You will also learn about this changes and of energy in physics class. You will learn that in the physics class that heat and light are the forms of energy. Energy can change its form from one form to another form. It can definitely change its form. You would also have heard the term kinetic energy, then we are having the term potential energy, and so on. Many types are there. So the two types we will be dealing with this in the topic related to the energy changes, heat energy and light energy. So when the change in energy is taking place, when a physical or chemical change is happening, that time when this change in energy is taking place, we will say energy is either taken in, that is called as absorbed, or in other ways we can say energy is given out, that is it is evolved or emitted by the substance that is undergoing the change. Once again I will repeat this line. Those who are following the textbook side by side, please mark this in your book. Energy is either taken in, that is absorbed, or it is given out, that is evolved or emitted by the substance that is undergoing the change. It may be a physical or a chemical change, but still we will say both these type of the energy changes are possible. How it is done, that all we will be seeing in the upcoming part of this video. So when we say that energy is absorbed or evolved, we will just in other words we can also say that heat energy or light energy, this heat or light is either emitted or it is absorbed. It can be absorbed, heat is absorbed, or heat is released. Same way light is absorbed or light is released. When we say heat or light, that means the same thing only, that is energy. That is energy only. So heat energy or light energy is absorbed or emitted by the substance during the physical or chemical changes. The energy changes that usually involve the heat only, light energy in some of the reactions we can see, but the majority of the reactions or the changes around us, they are having the absorption and release of the heat energy only. Let us see some important definitions related to these changes. So if the change is there in which the heat is evolved, heat is released or produced, we can say produced, or we can also write there heat is released. So a change in which heat is released or evolved, it is called as an exothermic change. On the contrary to this, a change in which the heat is absorbed, or we can say it is taken in, so then what we will say, then it is called as endothermic change. Please do mark this or tick this in your textbook for your revision. It will be helpful and you have to learn both of these definitions. Once again we will repeat. If in any kind of the change heat energy is evolved or released, it is called as an exothermic change. On the contrary, if in any of the change heat energy is absorbed, then it is called as an endothermic change. Sometimes the students confuse and they write the opposite, just like they can write in exothermic heat is absorbed and in endothermic they will write the opposite. So please take care, do not confuse. For your better understanding, I have a short trick for you so that you will not confuse now. So see this term here, exothermic. Out of this exothermic, take the prefix exo. Exo is related to the word exit. So when you exit from a place, what you are doing? You are going out of that place. You are going away. Same thing is happening in this reaction also. Heat is going away. Heat is released. Heat is evolved in the process. So heat is exiting that kind of the substance wherever the change is happening. That is what we call as, we are saying as exothermic change. This is just a trick so that you will not confuse between exo and endothermic changes. So I hope it is clear to you, and please do tick this in your book, and you have to learn both the definitions. Let us see the examples related to these changes in the physical and chemical changes. Both the type of changes, exothermic and endothermic, are happening. First of all, we will see both the exo and endothermic changes in a physical change. Let us see the example number 1, that is the changes in state. Changes in state means changes in state of matter. When the solid change to liquid, liquid change to gas, and opposite, gas change to liquid and liquid back to solid, that is change in state of matter, and it is a physical change. We have already seen it is a reversible process, that is why it is a physical change. So the energy changes are observed during this change in the state of matter. Like a solid has to be heated in order to melt. See, I am circling the important point. See, heated, we are heating the solid. What does it mean? It means the solid is absorbing the heat. This is the most important thing related to endothermic change. I have put that in the green box. You notice that word, absorbs heat, and when something is absorbing heat, we say it is endothermic change. So when solid changes into liquid, solid will change into liquid only and only on heating. That means the solid particles or the molecules present in the solid substance, they are absorbing the heat energy. And if they are absorbing the heat energy, that means it is an endothermic change. So when any kind of the solid substance like ice, sulfur, iron, all these substances are absorbing heat and they are melting, then what is happening is an endothermic change is happening. On the in the same manner, the liquid also absorb heat to change into vapor. Like water, if you keep the water on boiling, what will happen after some time? Water will evaporate and convert into water vapor. What actually has happened there? Actually, water has absorbed heat. So when water changes to water vapor or any other liquid changes to gas, that is what? That is also called as an endothermic change. I hope it is clear. It is a physical change and also it is an endothermic change. Water to water vapor, this change is called a physical change, that you know that we have discussed in the concept related to physical change. Also it is an endothermic change because there is an absorption of heat energy. Just opposite thing now, just opposite you do. When you are cooling down, on cooling down what will happen? If you cool down the gas or the vapors, then what will happen? Then you will get the liquid back. So same thing you observe in the rainy season. The clouds are releasing water. So in the summer season, when the temperature is very high, water evaporates, moves up in the clouds, moves up and form the clouds, and there water vapor is collecting. This same water vapor will cool down and come back in the form of the rain. It will come back in the form of the rain. So that is on cooling down it is happening. And when it is, we say that on being cooled down, what has happened there? Heat has been released there. And if heat is given out, it is called as exothermic process. Heat is exiting there, na? That is why it is an exothermic process. So I hope the concept is clear. Changes in state of matter. If heat is absorbed, changing of liquid to solid, changing of the solid to liquid, liquid to gas, that is endothermic change. But the opposite, changing of the gas into liquid and liquid back into the solid, that is exothermic change. Let me write it down for you. You can also write in a part of the book, solid to liquid, liquid to gas. All these things will require what? They will need some amount of the heat to be absorbed. Heat energy is absorbed here. But if you do the opposite now, if you do the opposite, that is if you are converting the gas to liquid and liquid to solid, that time what is happening? That time heat is released. Also we say it as evolved. Evolving means releasing only. And this is here we say it is what? It is exothermic change. So this is all. We have seen the first example. We have an activity related to this that we will read now. Boil some water in a kettle and place a bowl of cold water near its spout. So this is it. You can see this is the kettle they have taken. This is the spout, and from the spout what will come outside? Water vapor will come. If you are boiling water, water vapor will release from there, from the spout. So now water vapor that is coming outside here, you can see they have taken a bowl. This it is not visible, you can see in your book. We will keep a bowl. In that cold water is there, but the water vapor will come and strike on the wall of this container. As the water vapor that is coming out from this kettle, that is hot, and water is cool. Here we are having cold water is there. So when this hot water vapor is there, hot water vapor is released from the spout. You can see the heading point of the arrow. I'll make again. So water vapor is coming out from the kettle and it is striking on the surface of the bowl, and when this will happen, what will happen? Water vapor will also become cool, and cooling down what will happen? Water vapor will convert into water, and after some time you will observe that there are tiny droplets of water. The same water vapor which was coming, which is being released from the spout of the kettle, that is collecting on the outer wall of the bowl in the form of the tiny droplets. That is just because heat is released there. Heat is getting released there. So water vapor will evolve the heat because it is condensing and collecting there on the wall of the bowl that is having cool water. So this water vapor that is coming out will condense as it comes in contact with the bowl. After some time you will find water in the bowl also will become hot. That's just because that the cold water which is in the bowl, it is getting heat from the water vapor. So that is all. You can read this. I have already explained that thing related to the activity. Next example we will come and read now here is dissolution. So what about the dissolution? Dissolution means when we are dissolving anything. If we are dissolving any solid in a liquid, that is called as dissolution. This process of dissolving different things also has energy changes. That is, some substances are there which evolve, which produce heat when they are mixed with any liquid, while there are some other substances which absorb heat when they are dissolving in a solvent. Solvent is a liquid. The substance that we are dissolving is a solute that we have seen in the previous class. I hope you remember that. So let us see the example. When you put some glucose, take some glucose powder, put it on your tongue. You can do this at your home also. Take some glucose powder, put it on your tongue. What will happen? You will feel that your tongue will feel very, very cold. Why does your tongue become cold? What is the reason for this? So the simple reason for this is that when you are putting the glucose on your tongue, what is happening? The moisture, that is water only, that is on your tongue, it will absorb the heat. It will take the heat from the tongue by the glucose powder. The glucose that is present there, it will mix with the water on our tongue, or that is moisture in our tongue, and then glucose start absorbing the heat from our tongue. And when the glucose is absorbing heat, our tongue will become cold. It will feel very cool. So our tongue feels the cooling effect. So that is a particular example where heat is absorbed, and this process, this full reaction, absorbing of heat by the glucose on our tongue, it is endothermic change, because absorption of heat is going on here. So it is endothermic change. Just opposite you read now. Similarly, when you dissolve another, there is a chemical, ammonium chloride. Formula of this is NH4Cl. Ammonium chloride. If we take this in water, what will happen? The whole solution will become cool. Just the same thing only. The cooling effect is there. Ammonium chloride will absorb the heat from the water, and the water will become cool. It is also endothermic change. Just like the glucose only, ammonium chloride also absorb heat from the water. Now, on the other hand, if we take acid, if we take bathroom acid, that toilet cleaner, that is acid only. We do not have to touch this. It will burn our skin. So we do not have to be very careless or very lethargic with it. Very carefully, it has to be used. So children should not use that. Should not touch that. So concentrated hydrochloric acid is present in the bathroom acid, and when it is mixed with water, what will happen? Heat will evolve, heat is produced there. So that is what it is, exothermic change. Mixing or dissolution of bathroom acid, or simply you can say dissolving of acid in water, is exothermic change. So that is all. Dissolving of glucose and ammonium chloride in water is endothermic, and that of the bathroom acid is exothermic process. So that is all. We have completed the part of the physical changes and the related energy changes. Now we will talk about the energy changes in the chemical changes. So all the chemical changes are having the changes in energy. Like we will see the burning process. Anything is burning. Burning of any substance is irreversible process, and hence it is a chemical change. So like if coal or wood is burning, what is happening? When you are burning something, heat energy is coming outside. Also light energy is coming outside. In winter season, many people are burning coal or different wooden things, small pieces they are collecting in the roadside, and they are burning it. So why they are burning? Just to get heat energy. So heat is absorbed or released. Heat is released there. When anything is burning, heat is released there. So burning is therefore called as an exothermic process. And in fact, in burning, light also is emitted. Like if you are igniting a candle itself, or you can see in this photograph a matchstick is there, it is burning. So when it is burning, both the things are coming out from there. Heat is released, and also we'll write here heat released, and also what is released? Light also is released. Both the things are released in the same process, and hence because of the releasing of the heat, we will call it as an exothermic process. So that is the first example we have seen. Next is slaking of life. This is the process that is experienced when you are having whitewashing in your homes, painting and all. So that is all. When it is going on, we are using the chemical quicklime. In Hindi we call it chuna. So that is quicklime. So this quicklime, it is mixed with water. For whitewashing, we are mixing this with water. When it is mixed with water, what will happen? We are not taking hot water, we are taking normal water only. But this normal water only will turn into boiling water without heating. We are not heating water. But still, you take normal water, put some quicklime. The water will start boiling. It will boil on its own. You will see bubbles arising in the water like it is boiling. It will become so hot that it appears like boiling water. What is the reason? The reason is simple. That is the reaction between quicklime and water is exothermic reaction. The reaction is so highly exothermic. We'll read this line. The reaction is so highly exothermic that water added starts boiling. So whenever a small amount of water is added, the water quickly vaporizes with a hissing sound, and with a large amount of water, a thick white paste of the slaked lime is formed. What is obtained there? When quicklime is mixed with or dissolved in water, we are getting slaked lime, and this slaked lime only we are applying on our walls. That is how whitewashing is done. So this process is called as slaking of the lime. You can see this photograph they are shown here. This PDF, it is not clear. You can see in your book. You will see bubbles in this particular container. This is a quicklime mixed with water. This is slaked lime. Slaked lime we are using for whitewashing. You can mix different colors also in this, according to the color you want on your walls. Normally it is white color. Quicklime is white color. If you want white color walls, no need to put any color. Directly you can apply on the walls. But if you want any color or any shade according to that, you can choose any kind of the color and mix in this. Next is photosynthesis. Another and the last final example we'll read now. Photosynthesis in green plants. That is a biological process, and it takes place in the plants to produce the food. Plants are autotrophs. You have studied that in biology, that plants are having the ability to produce their own food, and that is this process only. Photosynthesis is the process by which plants prepare their own food. That is happening in the presence of sunlight. Also this is happening by because of the pigment that is there. Chlorophyll is there in the green leaves. That is the green pigment of the leaf. This chlorophyll is doing what? And what is the role of chlorophyll in photosynthesis? The chlorophyll pigment, that is green pigment, it absorbs the sunlight or the solar energy. Sunlight is energy only, solar energy. So plants are getting this energy, they are absorbing the energy. Once again, I will just underline the important part for this concept: absorbs energy. So just recall where absorption of energy is there. It is called as endothermic change. So that is all about this photosynthesis. In this process, manufacturing of food of the plant is there, and this is happening because the chlorophyll pigment in the leaves is absorbing the energy. Which energy? Sunlight energy or solar energy, and thus it is endothermic change. This process will help the plant produce the glucose, that is actually the food only for the plants, and indirectly for us also. We are eating vegetables and different fruits and all. They are also having the same food, and we are getting this food. So glucose and oxygen is available by the process of photosynthesis. Oxygen we are getting from the plants, and that is helping us to breathe and continue our lives. So that is all. We have completed this chapter and its various topics. If you are having any doubt related to the present video or any other topic related to this chapter, do post your queries in the comment section below. Else you can directly send your question or queries or doubts to me on the Teams app in the personal chat option. Just send the message and I will be happy to help you. Else you can ask to the teacher taking the live classes on the Teams app. That is all for this class. Students, do read and revise, and we will take a halt for this video. Thank you everyone.